Okay, on this video I'm going to answer questions from the 2015 AP test. I'm going to solve questions 4 and question 6 from the AB 2015 exam. Now for you BC students tuning in, question 4 is also from your exam. So this question 4 was on both the AB and the BC test. All right, so we'll start with question number 4. Question number 4 is a differential equations problem, and they give us a differential equation. Now, remember, a differential equation is an equation that involves a derivative. So we have dy dx equals 2x minus y. So we have an equation, and one of the factors in our equation is a derivative. This is y prime. So this is the slope of some function that we do not know. We don't know what y is. We know what the derivative of y is. The derivative of y is given by 2x minus y. That's what we know. Now remember, derivatives are slopes. So this is the slope of our equation. We do not know what our equation is. If we solved this, if we did something like this, if we moved the y over here, made it a positive, right, move it over here, the best we can write is y equals 2x minus y prime, right, because that's y prime. Well, that doesn't tell me what my function is. That tells me my function in terms of y prime. It doesn't tell me the value of y. So I do not know what my function is. My function is some function, right, some function whose derivative equals this, right? It's a function whose derivative equals this. Now, what does that mean? That means we know the slope. We know the slope of our function. This is the slope of our function. That's all we know. Now in part A, they ask us to draw a slope field. Now a slope field is a photograph, a picture, a graphical representation of the slope of our function. And typically on the AP exam, the way they ask this question is they give us some points. They tell us where to find the slopes. So in the problem we were given, in our answer book to this question, there would be a dot at a 1, a dot at 2, then there's 1 here, there's a dot at 1, 1, a dot at 1, 2, and then down below there's a dot at negative 1 and a dot at 1, negative 1. And the instructions say, on the axis provided, sketch a slope field for the given differential equation at the 6 points indicated. So this is what our answer document would look like. And in the question says, find the slope at the 6 points indicated. Now our job then, is to keep in mind that this, right here, this is the slope. So if they want to know the slope at this point, right, this point, that's the point, x is 0, y is 1, right? That's the point, x is 0, y is 1. So if I want to know the slope there, I have an equation that will allow me to find it, right? So we could make a t-table. You don't have to do this. Typically we do this in our head, but I'm trying to teach you here. So this is the point 0, 1. This is the point 0, 2. This is the point 1, 1. This is the point 1, 2. And what do they want me to do? They want me to find the slope at each of these points. And I have an equation that tells me how to do this. This equation says to find the slope, I multiply x by 2 and I subtract y. Well, x is 0. 2 times 0 is 0, minus 1, so my slope is minus 1. I plug this into the equation that tells me my slope. X is 0, y is 2. This turns out to be negative 2. X is 1, Y is 1. So that's 2. 1 times 2 minus 1, that's positive 1. X is 1, Y is 0. Sorry, that's the answer. X is 1, Y is 2. So 1 times 2 is 2 minus 2, that's 0. Now what does the answer to my problem look like? The answer to a slope field question is we draw a picture that shows me the slopes at each of these points. So let's take the point 1, 2, for example. The point 1, 2 is here. Our slope is 0. So we draw a little line through that point that has a slope of 0. So we're making a picture of the slopes. Now what about the point 1, 1? At the point 1, 1, our slope is 1. We know a slope of 1 is a 45-degree line, so we just make a little dashed mark on our answer document that looks like this. What about x is 0, y is 2? That's this point right here. Our slope is supposed to be negative 2. So we know it's negative, and we know it's negative 2, so it's a little steeper than negative 1. So we make it, we just estimate it, right? We just estimate it. We don't have to draw, get out a compass, plot points, do anything crazy. Now here our slope is negative 1. Negative 1 is going to be a 45-degree line, negative. See how this one's a little steeper than this one. So now we'll do this one in our head, right? This is the point x is 1, y is negative 1 here, right? X is 1, so that's 2, minus 1, that's going to be a slope of 3. So a slope of 3, positive and a little steeper than a slope of 2. What's this point? This is x is 0, y is negative 1. 0 minus 1. So if you're thinking to yourself, all I do is plug those in, yes, that's what you do. You've drawn a picture. Now, we don't know what the function looks like. We don't know what our function looks like. But we know when our graph comes through here, its slope is going to be 1. And then when our graph goes through here, sorry, negative 1. And then when our graph goes through here, its slope is going to be 1. The graph is going to come through here, and then as it approaches this point, it's going to have a slope of 0. We don't have our graph, okay? We don't have a graph. We have a picture of the slopes of our graph. That's what we have here, all right? And so that's the answer to part A. Now part B says, find the second derivative of y in terms of x and y, and determine the concavity of all solution curves for the differential equation in quadrant 2. Give a reason for your answer. So part B says to find d2y over dx squared. And we have to remember that this is the formula for the second derivative. We're used to seeing f double prime or y double prime, but this is also a representation of the second derivative, and we have to recognize that. We can't sit for the AP exam and not know what a second derivative looks like. So what do they want me to do? It says find the second derivative, right? So we want to find the second derivative of this function. Now we're finding it in terms of x, right? We're finding it in terms of x. So we're taking the derivative. We know we're taking the derivative in terms of x. So we take the derivative of 2x. The derivative of 2x is 2. Then we take the derivative of y, right? What's the derivative of y? It's not 1 because we're taking the derivative with respect to x. The derivative of y is going to be y prime. Because we have to remember that we're not differentiating with respect to y. If we were taking the derivative with respect to y, sure, the derivative of y is 1, but we're taking it with respect to x. So the derivative of y is y prime, and maybe even a better way to write that initially would be we're taking the derivative of y with respect to x. And then maybe we see this when we write it down and we say, oh, okay, that's 2 minus y prime. Now, it says to discuss concavity. The second derivative tells us about concavity, but we look at this and we're like, how am I supposed to talk about concavity in quadrant 2? They want to know what's the concavity in this quadrant for our function, right? Quadrant 2. How am I supposed to find that? This is a y prime. Well, We know y prime. Remember, this is another symbol for y prime. So this is a vocabulary question. We can substitute in y prime. And that gives us the second derivative as 2 minus 2x plus y, right? When we do our distributive property here. So the secret here is to recognize this is a second derivative. Take, in terms of x, take the derivative of 2x to get 2, take the derivative of y to get y prime, dy dx, substitute in what they told us was y prime, and now simplify. Now somehow or another, we're supposed to be able to make some sweeping statement about concavity in quadrant 2. And what do we know about quadrant 2? Well, in quadrant 2, we know that our x is negative and we know our y is positive, don't we? Isn't that what we know? X is negative and y is positive? That's true for every point in quadrant 2. And what they say in the problem is, determine the concavity of all solution curves, right? So for all of our curves y, again, we don't know what our curve is. We don't know what our solution curve is to this differential equation. We don't know our family of curves. This is not a differential equation we can solve. We don't know how to solve this. We know how to solve what are called separable differential equations. That's not a separable differential equation. So I can't solve it. So they've taken the differential equation problem where I know how to solve separable differential equations. That's what my teacher taught me. And they've taken away that from us. They've said, okay, we know you can do the mechanics of solving a differential equation. But can you work with a differential equation? Is that all you can do? So they're asking us questions that are associated with differential equations but don't involve us solving differential equations. Very typical of the College Board. So here's our differential equation. We know the second derivative is this. Now what do they want us to do? They want us to talk about concavity. Remember, concavity has to do with the sign of the second derivative, right? That's when we talk about concavity. We do the sign test with the second derivative, and we say, okay, if the second derivative is positive, we're concave up. If the second derivative is negative, we're concave down, right? Well, what do we know about quadrant 2? Well, there's some things we know. For example, in quadrant 2, we've written it over here. X is always negative, and y is always positive in quadrant 2. Well, look at our second derivative. If x is always a negative number, what happens when I take a negative number times negative 2? And I get a positive. And y is already positive. So I have positive 2 here. I now have a positive number here, and I have a positive number here. So we could say, since x is negative and y is positive, in quadrant 2, we know that the second derivative is always positive. Thus, all solution curves are concave up. Because if the second derivative is positive, then we're concave up. So that's what they wanted us to do for part B. Part C says, all right, suppose I gave you a solution, right? Suppose it says let y equal f of x be a particular solution to the differential equation. So we know our solution is some function y equals f of x. If we knew how to solve this, we would get that solution. We don't know how to solve it. They gave us a problem on purpose that we don't know how to solve. So they want us to just work with the concepts instead of the mechanics. That's what the College Board expects for us. They expect us to understand the concepts. So if that is my solution, and I have an initial condition that f of 2 equals 3. Now what does that mean? That means when x is 2, y is 3, this point right here, our graph goes through that point. It goes through the point 2, 3. Okay, our graph goes through that point. Does f have a relative min, a relative max, or neither at x equals 2? Justify your solution. Okay, justify your solution. So they want to know what's happening when x equals 2. When x equals 2, we know y equals 3, right? That's what it says right there. They want to know about mins and maxes. What is it that we use to determine mins and maxes? Do we use the second derivative? No, that's concavity. We use the first derivative, right? The first derivative. So, what do we need to know? We need to know if this function is positive, this function, the first derivative, if the first derivative is positive on one side and negative on the other, right? If the first derivative switches from positive to negative, we would say we're going up, and now we're going down. We would call that a relative max. If the first derivative switches, this is 2, right? If the first derivative switches from negative to positive, we would say we're going down, now we're going up. We would call that a relative min. If it doesn't do that, right? If it doesn't do that, then we don't know. Now, before we can do any of this analysis, 2 must be a critical number, right? We said the only place we have relative mins and relative maxes is where we have a critical number. So before we can worry about, oh my gosh, how do I tell if the derivative is positive or negative on both sides of 2? Well, you know the derivative right here, right? You know you know the derivative. But how do we know? Well, 2 has to be a critical number. So let's find out if 2 is a critical number. 2 would be a critical number only if the derivative, when we plugged in x is 2, y is 3, this is supposed to be 0. That's what makes it a critical number, or it fails to exist. We remember, we only have mins or maxes at critical numbers. That's what they're testing you on here. What happens when you plug in x is 2, y is 3? You get 2 times 2, right? X is 2, y is 3, minus 3. This is 1. That's not 0. So, 2, 3 is not a critical number. Therefore, 2, 3 is neither. Because to be a relative max or a relative min, it would have to be 0. And it's not. So since it's not 0, we don't even have to worry about doing the sign test. What about part D? Find the values of the constant m and b for which y equals mx plus b is a solution to the differential equation. Okay? So they're telling us that our solution, I'm going to go ahead and clean some of this off. They're telling us that if we were to solve this, which we do not know how to do, right? We do not know how to do that. This is not a problem that's separable. Therefore, it's not a problem that we can solve. But they're telling us in part D, if your solution, right? If your solution, right? We know what the derivative is. They're saying your solution is a line, mx plus b. They're telling us the solution to this is some line out there, right? It's some line. And it says, tell me which line it is. What line is it? Which line, out of all the lines that look like y equals mx plus b, which one is going to be the solution? Well, we know the derivative of our line is 2x minus y, don't we? So let's take the derivative of both sides here. We'll take the derivative of this side. After all, we were given that. We'll take the derivative of this side. And when we take the derivative of that, the derivative of m times x is m. So we know our derivative is m, right? Our derivative, if this is indeed my answer, the derivative of my answer is 2x minus y. But if this is indeed my answer, its derivative is also m, so we know that m equals 2x minus y. That's what we know right now, okay? That's what we know right now. But we also know who y is. They told us our answer. They told us y is mx plus b. So we can write this as 2x minus y, which is mx plus b. And that gets us, if we solve this, right? If we solve this, we get 2x minus mx minus b. I distributed. That's going to be 2 minus m, right? Times x minus b on that side, right? Isn't that true? Now, well, before I do that, I guess before I do that, I probably should have brought the m over here, because now I have this factored. I can't get the m in there very easily. Looking at this now, right? Looking at this now, maybe this would be better if I move the m over here. If I move the m over here, what do I get? So we get, if we move the m over, we get 0 on this side, right? 0, because we're going to move the m over here. Now we're going to have 2x minus mx, right? Minus b, right? We have the minus b here. Now we've brought the m over, so we have minus m. Now we're going to factor this, right? We're going to factor. What can we factor out of these two terms? If we factor an x out of these two terms, we're going to get 2 minus m. If we factor a negative 1 out of here, we're going to get b plus m. Now this equals 0. So what does that mean? Well, it means this person's got to be 0, right? Because there's no x term over here. There's no x term. So 2 minus m must equal 0, but that tells me the value of m. It tells me m equals 2, right? M equals 2. Now, by the same argument, there's no b plus m over here, so b plus m must equal 0. But we now know the value of m. We now know m is 2, so b plus 2 has to equal 0. So b has to equal negative 2. And now we're done with that part. It said find the value of m and b. And we did. M is 2 and b is negative 2. All right. So that completes problem 4 from both the 2015 AB and BC test, right? Both. So at this point, I'm going to solve question 5 from the AB test. So all of you BC students, you can now stop watching this video and pick up the video for the remaining problems from your test, because questions 5 and 6 from your 2015 test are not on the AB test. So you would not be able to find solutions on this video. You've got to go to the 2015 BC question 5, question 6 video. All right, so for you BC kids, away you go. For you AB kids, here we go with question 6. So question 6 on the AB test, right? Question 6 was consider the curve given by the equation. So question 6, right? This is question 6. They gave us an equation, y cubed minus xy equals 2. All right, so we have this curve. We're not asked to graph it or anything. It's just we have this curve. And it says, just to save us from having to do the work, it says if you want to find the derivative of this, which we're apparently going to need to solve the problem, they tell us if we find the derivative of this, which we would have to use implicit differentiation to do, so they're just saving us time here. The derivative is y divided by 3y squared minus x. That's our derivative. Okay, so apparently at some point in this problem we're going to need the derivative. They didn't want us to take the time to find the derivative, and so they have given us the derivative. So we have a curve, right, which we don't know what it looks like, and we don't care apparently because they didn't ask us to graph it. So part A says write an equation for the tangent line at the point -1, 1, right? That's part A. So they need the equation of the tangent line. At -1, 1. All right, now we know the equation of the tangent line comes from y minus y1 equals m times x minus x1. All we do have to do is turn this into calculus. And so we wrote our equation of our tangent line is y minus f of a equals f prime of a times x minus a. This is the equation of our tangent line. Now they want the equation of our tangent line when x is -1, okay? But we also know the y value there. They told us the y value there is 1. So the equation of our tangent line is y minus 1, right? That's our y value, equals our slope. Now we don't know our slope yet, so that's going to be f prime of 1, right? F prime of 1. And now we have x minus 1 here. And of course, it's not really f prime of 1 because our slope has an x and a y in it. So it's really f prime at the point -1, 1. And we know how to find that. We put 1 in for y, 1 in for y. We put -1 in for x. So the equation of our tangent line is y minus 1, right? Y minus 1 equals our slope. So what's our slope going to be? Well, we're going to have a 1 on the top. Y is 1. On the bottom, we're going to have 3 minus minus 1. So we're going to have 4 there. And we're going to have x minus 1. And there we go. That's the answer to part A. Okay. So we found the equation of our tangent line. Part B says find the coordinates of all points on the curve at which the tangent to the curve is vertical. When is a tangent line vertical, right? That's what they're asking us about in part B. We know vertical tangent lines occur when the slope is infinite, right? Vertical tangent lines. That would happen when our denominator equals 0. So when is our denominator going to be 0? Well, we have the denominator. It's 3y squared minus x. That's going to equal 0. We know how to solve that. We get 3y squared equals x, right? 3y squared equals x. Now, if 3y squared equals x, then we can put 3y squared in here for our x and solve to see what y is going to be. 3y squared equals x. We know that y cubed minus x times y is equal to 2. So if I put this x here, I can rewrite that equation as y cubed, right? Y cubed minus x. X is 3y squared times my y equals 2. And if I solve that, right, I have y cubed minus 3y cubed equals 2. I have -2 y cubed equals 2. Or I get well, let's just make it positive y cubed equals -1. Well, what do we take the cube root of? We take the cube root of both sides, and that gives us y equals -1. Right? And it says find the coordinates for all the points on the curve. All the points on the curve. Well, we know y, we don't know x. So we go back and we plug it in. This is our curve right here. We plug it in. We get -1 cubed minus x times negative 1 is supposed to equal 2. So we get negative 1 plus x equals 2, and that gives us x equals 3. So our tangent line is vertical, right? We have a vertical tangent line at the point 3, and we got y to be negative 1. So that's the answer to part B. Part C says, find me the second derivative. Once again, they've used the notation d2y over dx squared. They want us to find the second derivative at the point negative 1, 1. Well, the first thing we have to do is find the second derivative. Before we can plug in negative 1, 1, we have to find the second derivative. How do we do the second derivative? We take the derivative of the first derivative. That's how we find the second derivative. So they're going to make us do the quotient rule, right? So we write down the denominator, 3y squared minus x, times the derivative of the numerator, which is going to be dy dx, right? Because the derivative of y is dy dx, minus, right? Minus the numerator, right? The numerator, which is y, times the derivative of this. Well, we're going to have to use the chain rule, so that's going to be 3 times 2, y to the first power, right? But then we got to take the derivative of y, chain rule, so that's dy dx, minus the derivative of x, which is 1, all divided by the denominator squared. So that's my second derivative, right? And it's a bit messy, but it's okay that it's a bit messy because we know the point where we want to find the value. Remember, we want to evaluate when x equals negative 1 and y equals positive 1. I believe that's what they asked us to do. So now what are we going to do? We're going to stick those numbers in here. That's what we're going to do. So we get the second derivative of y with respect to x evaluated at the point negative 1, 1 equals, and now we're just going to do a lot of substitution, right? This is going to be 3 times 1 squared minus 1, right? Because x is negative 1, times the slope. Well, we can get our slope from here. And in fact, we've already done that earlier in the problem, right? Earlier in the problem, we found the slope at the point negative 1, 1, didn't we? And we found it to be 1/4. So that goes here. Minus y, which is 1, times 2 times 3 is 6. This is y to the first, and we said y was 1, times the derivative, which we just said was 1/4 minus 1. All divided by 3y squared minus x, so that's going to be 3 times 1 squared minus 1, and now we square all of that. Now I'm not going to do that arithmetic. You can do the arithmetic. When you get all done, the answer turns out to be 1/32. Okay, so that finishes question 6, and that concludes the 2015 AB test. All right, so your next exam is going to be the 2016 exam, and I will again do solutions for that. All right, keep working hard.